Okay, in this little activity, we're going to look at graphing straight lines and how you graph straight lines. So what we've got here is a formula or a function, y equals 2x minus 1. We've got a whole heap of x values. So when x equals 1, it's 2 times 1 minus 1. So 2 times 1 is 2, minus 1 is 1. And here's our x equals 1, y equals 1. So all we're doing is plotting points. So when x equals 3, you get 2 times 3 is 6, minus 1 is 5. So when x equals 3, y equals 5. When x equals 2 here, 2 times x is 4, minus 1 is 3. And what you see is we are getting a straight line, or what looks like a straight line. 2 times 0, when x is 0, minus 1 is going to give us minus 1. And again, it looks like we've got this straight line happening. And when x equals minus 1, 2 times minus 1 is minus 2, minus another 1 is minus 3. And so what we've got is a whole heap of points there. Remember, we plot the x first going across. So this is the point 2, 3 here, over here. So 2 across and 3 up. Now what you see is that if we put a line through that, there's our straight line, or this line here that I've just put through is our y equals 2x minus 1. Now these x values could be in order, but I've purposely not put them in order. Let's see how it works in another example. We've just got x plus 1, a nice simple x plus 1. So when x equals 2, y is going to be 2 plus 1, 3. When x equals 1, we're going to get, so we're putting the 1 in here for x. 1 plus 1 is 2. When x is minus 1 over here, minus 1 plus 1 is 0. When x is 0, we get 0 plus 1. And this is a fairly easy one. As you can see again, what we've got is a straight line. Nice, simple straight line. And we can join those points together, and there's our straight line, y equals x plus 1. Here we've got a slightly different one because it's y equals 5 minus 2x. So it's sort of a bit backwards there. We've got to do the x first, order of operations. 2 times 2 is 4. 5 minus 4 is 1. When x is 1, 2 times 1 is 2. 5 minus 2 is 3. Again, what we should be seeing is a straight line, hopefully. 2 times 0, we're putting 0 in here, is 0. So 5 minus 0 is 5. And when x is 3 at the end here, 2 times 3 is 6. 5 minus 6 is minus 1. And again, we've got this straight line. Now, what you should notice about that straight line is it's going the other way. It's going downhill. If we're reading this way across, this one's going downhill. Why is this one going downhill compared to these, which are all sort of uphill as we read across? Uphill, because of this positive 2x. This one is positive 1x. So again, it's going uphill. This one is a minus 2x. So that's why it's going downhill. And we'll get into that in later lessons. And the last one, y equals 2x minus 3. So again, we should be getting something that's going uphill. And in this case, I've put these values in the x in order. So when x equals 0, 2 times 0 is 0. So you just get minus 3. There's the point, 0 minus 3. When x is 1, you get 2 times 1 is 2. Minus 3 is minus 1. Now, we would expect the next point to be up here and then up here, because we are looking for that straight line. 2 times x is 4, minus 3 is 1. It's exactly where we thought it would be. And again, where would we think this? If it's a straight line, it should be the point 33. 2 times 3 is 6, minus 3 is 3. And there's our straight line. Okay, so that's how you plot points. We could choose any values for our x. We could use 0.1365, but why would you? You try to use nice, simple numbers. It doesn't always have to be a straight line, but in this case, we are looking at graphing straight lines. That was the whole point. That's how you graph a straight line on the Cartesian or the number plane. Thanks. And if I turn it off, that would be good.